find the voltage? Given the current, how do you find the voltage for a capacitor? The voltage across capacitor. I'm waiting for somebody to tell me how you find the voltage across capacitor if you know the current through the capacitor.
Dr. Godray.
Yes?
I might have been one of the complicated people, but I did the area over C, but I think you wanted us to do via T equals 1 over C integral of T and 0 I dft plus VO.
No, if you ask him, did I want you to do it by calculus? The answer is no, I did not want you to do it by calculus necessarily. I didn't tell you how to do it. Okay, so when you find the area, what are you finding? When you find the area, what are you finding?
The tangent.
Tangent? Oh man, you clearly don't know what a tangent is. Folks, I've got how many people in this class right now? I've got 6 people in this class right now. I'm talking to all 6 of you. When you find the area under the curve, what are you finding?
The integral.
The integral, yes. I don't know why you're mumbling. Well, I don't know whoever you are. By the way, I can't tell who's speaking. You find the definition that I gave you in this class is a voltage at any given time is 1 over C, integral from 0 to T, I dt plus V of 0. That here, that is our definition. Okay. Now, I asked you to find V, in this example, V of 22. V of 22 equals 1 over 3, 0 to 22, I dt plus V0. V0 is 0. What is this? What is that?
Area under the curve.
Area of the curve from where to where?
From 22 to 0.
No, from 0 to 22.
That's up.
There's a difference. The area from 22 to 0 is negative of the area between 0 to 22. All right, so that's all this area here. That's all that area there. And clearly that's the area. That's the area of a triangle, which is half the base, which is 22, times the height. So in this example here, that is 110 divided by 3, 36.67 volts. It was as simple as that. And people manage to screw it up. No, any questions about that?
Dr. Cartwright, I think I did that for my homework, but you marked it wrong.
Who's talking?
So this is Stuart.
Let me just bring up. Let me just look at your homework. There were 1 or 2 I had correct. Well, Mr. Stewart, let me check on that, okay?
Yes, sir.
Okay. I'll get back to you today. And if that's what you did and I marked it wrong, I apologize. If that's not what I did, though, let's see if I can find it real quick. Because
Dr. Godred.
give me a second here. Yes? Yes?
Yeah, this is Stanley speaking. I use the same formula you use. Would you just
No,
write
you did
down?
not. Mr. Beauchamp, right?
Mr. Godred, you won't even let me finish speak?
Well, go ahead, speak.
I just use the same formula you used just now. I just used it just now. And I got the same answer.
Yes, Mr. Beauchamp, you got the right answer the wrong way. That's not a right answer. You got the right answer the wrong way.
But I ain't supposed to get at least one little 2 points for that.
I gave you a couple of points for that.
And I see -6. That's almost.
Yeah, I know, that was worth 4 points. I mean, that was worth 10 points. I gave you a couple of points for that, even though it is by accident you got the same answer. I can show you in a minute, Mr. Beauchamp, why you're wrong.
All right.
All right. Let's do it. Mr. Stewart, look very carefully at your answer. Your answer's not right. Look very carefully at it. Are you dividing by 3?
No, the bottom number is 2.
So where you got that formula from?
That's 1/3 times, rather than having the 1/2 multiplying the 1/3, I divided the whole thing by 2
Yes.
to get half of it.
Yes. So you were not careful. Okay. Okay. Any other questions?
Is that not the same thing?
Actually, it is. I'll look at that again, okay?
Yes, sir.
Okay. But it's just a weird way of doing it, Mr. Stewart. Okay. But numerically, it's the same thing. Okay. I'll look at that again. Anybody
Yes, sir.
else? Okay. All right. So I hear all you have to do is find the area under the curve between 0 and n+2. That's all you had to do, and divide by 3. Okay. Now, all of you got the straight line question right, except you don't know what function you're plotting. Okay. You're plotting I of t, not plotting V of t. This is a graph of I of t, not a graph of V of t. As a matter of fact, what do you think V of t is going to look like? Out of curiosity, what do you think V of t is going to look like? Somebody turn the mic off, please. If you're not answering, turn your mic off. What do you think V of t is going to look like? Well, I'll tell you, one person tried to do it this way. He tried to find V of t first. And then from the equation of V of t, write in V of n plus 2. Okay, but in fact, V of t, and he said V of t was a straight line function. V of t is not a straight line function. V of t is in fact a quadratic. Okay.
Dr. Cartwright,
Yes.
I have a question, right? Okay, with the homework, I mean, with the last assignment, right? When current goes to n plus 2, that's 0.
Current does not go to n plus 2. Current does not go to n plus 2. Time goes to n plus 2.
Okay, but the amount of amperage is shown on the graph at n plus 2, right?
Yes, it is 0.
Right. So
But that's not what you said. But that's not what you said.
But when you put it in this equation here, the answer is 0 though.
The amplitude of n plus 2 is 0. Yes.
So voltage at n plus 2 is 0. I mean, the amperage at n plus 2 is 0 amps.
No. Current at n plus 2 is 0.
Right. This. Oh, okay. All right. Okay, this is what I'm saying. When you put your n plus 2, phi of n plus 2 equals 1 over the capacitance, and you put
V. This is not an equation of V. What do you mean? For what you calculating voltage now? You calculating current? What are you doing now?
I'm trying to calculate the voltage at n plus 2. You put
Go ahead.
You put it in the function.
You put in what function?
In this integral, then.
That's one way of doing it, but I doubt that's the way you did it. That's one way of doing it.
But that's how I did it, and the answer I get was 0.
And that's wrong.
Why? That's what I'm asking. Like, if how could it be wrong if that's what the integral say the answer is?
No, the function does not say. The function does not say. You take the current. The voltage is proportional to current. The function does not say that. What does the function say, Mr. Pintard?
Define the voltage.
What do you do with that? What do you do with the current?
What do you mean? What do I do with it?
What do you do with current? You do not. The voltage is not proportional to the current.
Okay, this integral which you have circled here. If I want to find the voltage at a particular time, right? I plug
yes. So let's call this here. Let's call this n plus 2. And let's call this here n plus 2. All right. Now, what is this equation saying?
Right.
What is this equation saying? Tell me in English what the equation is saying.
The voltage. That's the voltage at n plus 2. I don't understand you.
Yeah, and what does it equal, Mr. Pintard?
What does the voltage equals? I don't know.
Yes. The equation is telling you. The equation is telling you what it's equal to. The equation doesn't say where you see I put 0. The equation doesn't say that. That therein lies your problem. Therein lies your misunderstanding. The equation says the voltage of n plus 2 is n plus 2. It has to do with what? The area. This is the area. The area between 0 and n plus 2. What is that? That's not the value here. That's the value of all this. The voltage is proportional to the area. You understand that, Mr. Pintard?
That's all.
Does that clear it up for you?
Yes, yes, yes.
Okay.
I don't know if it's my Wi-Fi, but you starting to lag a little bit.
Yeah, you are lagging.
I can't help it if I'm lagging. What you want me to do if I'm lagging? I pretty much I'm lagging. But what you want me to do about it?
No, ain't nothing. Sometimes when you talk a bit fast, it'll take a bit of time to come through, and I wouldn't be able to understand everything.
Yo, man, if you didn't get what I said, please ask me.
That's a
Do you still have a question?
I don't have no questions, no, sir.
Alrighty. Unfortunately, that's a problem with the technology. If the internet connection is not what it should be, then it's going to lag a little. Okay. My point I was trying to make is some of you still don't have through your head the voltage is not proportional to the current. The voltage is proportional to the area under the current. Okay. Now, I'm going to do the same problem, but I can do it the calculus way. Just now we did it the geometry way. Now I'm going to do it the calculus way. And after all, this is a calculus-based course. Okay. But to do that, we're going to need to know the current as a function of time. So we need to know the equation of this straight line. So I of t is equal to 0 amps, for t less than equals 0 seconds. I of t equals, what is that? 10 over 20, a half t. Okay. A half t for 0 is less than t is less than 20 seconds. And then we have negative 5t, negative 5t plus what? Is that, what's the intercept? Anybody, what's the intercept? What's the equation of this straight line here? Anybody? What's the intercept? What's the intercept of the straight line?
Dr. Cartwright, I don't know if it's just me, but my screen blanked. I can't see nothing.
I don't know why that is, because my screen is fine. My other screen is fine. Anybody else having blank screen problems?
No, sir.
Well, I get log out and log back in.
Yeah, sure, please do.
All right.
I'm asking for somebody to give me the intercept of that straight line, that second straight line.
Dr. Cartwright.
Yes.
I only know the y-intercept when it intersects in the y-axis. I have problems when it ain't like that.
Well, young man, we are not going down that path anymore. I've shown you how to do that now 3 or 4 times. I'm not going to show you anymore. It is your responsibility to learn what you don't know. And it is your responsibility to do that when we're talking about a subject. We have now done this. This now must be the 5th or 6th example we're doing. So I suggest that you get a YouTube video that tells you how to find the equation of a straight line. Because I'm not going over that again. $110, thank you very much. And what do we call this equation? What do we call this equation?
Piecewise linear description. Linear equation. Sorry.
Yes. Yes, piecewise linear equation for I of t. We need that to do it the calculus way. Give me a second. Okay. Now, let's do that same problem over, but the calculus way. So, v of 22 equals 1 over c, 0 to 22 I dt plus v of 0. V of 0 is 0. Okay. What's wrong with this integral? Why can't we do this integral? Why can't we do that integral?
Because the current is V22 is 0 amps.
No. Look at IT. Look at IIT. What do you notice about the IIT over 0 to 22? What do you notice about the IIT? It's 2 different functions. So you got to integrate one function from 0 to 20 and another function from 20 to 22. So you split this integral into 2. So this becomes the third 0 to 20, 0 to 20 I dt plus the third 20 to 22 I dt. From calculus, you should know that. From calculus, you should know you can split the integral into 2. All right. Everybody with me?
Yes, sir.
All right.
Yes, sir.
So this now is a third, 0 to 20. What's the first I? The first I is a half t. That's the equation of the first I. The equation of the second I, 20 to 22, is negative 5t plus 110. And now we evaluate this. Okay. Integral of half t is what? A half t squared over 2. Integrate from 0 to 20. Okay. Plus the third. Integral of negative 5t squared over 2. Plus 110t. 110t evaluated between 22 and 20. Okay. So this here is 12. Okay, that's 20 squared over 12. Okay, minus 0. And this one here is plus the third minus 5 halves times 22 squared plus 5 halves, 20 squared plus 110 times 22 minus 110 times 20. So that's 20 over. So let's find out what this is. 5 divided by 2 times 22 squared minus plus 5 divided by, what's that? 22 squared. I hope somebody's checking my work for me. Negative 1210 plus 1,000 plus 110 times 22, 24, 20 minus 110 times 20, 2200. So all that becomes V of 22 equals, the second half becomes 2250 minus plus 2420, plus 1,000, minus 1210. Hey, I'm still calculating this. I hope you all calculated it well.
I got 36.66.
And that's exactly what we got, didn't we? Yes. 36.66. And last time we got what? Didn't we get 110 over 3? Wasn't that what we got? Yeah. 36.67. Okay. The rest is round off error. So that's how we can do it the calculus way. As you can see here, the calculus way is longer. Doing it by geometry was quicker. But we need to know how to do it by calculus because there are some areas we could only calculate by calculus. All right. Any questions about this example? Because I'm going somewhere with this. Everybody understood what I did?
I did, yes, sir.
Okay. I guess-
Dr. Ga-
Go ahead.
what am I inputting in my calculator?
What does that
Which
mean?
line?
What do you mean which line?
I was trying to get 36.
You're calculating the very bottom line.
Starting from the 33.33.
Yes, you're calculating the very bottom line.
All right, because I got a high number. In the bracket, is that negative 1210?
Yeah, and where did that come from?
Would that be from the negative 5 over 2 times 22 squared?
Yes.
The last number in the bracket, would that be 222? Negative 222?
No, 2200. Negative 2200.
Oh, okay, yeah.
And where did that come from? Where did negative 2200 come from?
Negative 110 times 20.
Yes. All right. Now, I hope you followed that. Let me go through it one more time. We wanted to know the voltage at t equals 22 seconds. Okay. Voltage at 22 seconds. And what is that equal to? The area from 0 to 22. Area under the current curve divided by 3. But to find the area from 0 to 22, we have to split that integral into 2. 0 to 20 and from 20 to 22. Why? Because the current is different for those two areas. And that's what we did. For the first segment, the current is a half T. For the second segment, the current is negative 5T plus 110. And the rest is calculus. The rest is how we integrate. The rest is what I will not teach you in this class. The rest is what you should have learned before you came to this class. You're supposed to have Math 171 for this course. I made that very, very clear on numerous times. Okay. Now, I want to do something different now. I don't want the voltage at 22. I want the voltage at the time, but the time between 0 and 20 seconds. I want that voltage at this time here. The current is this amount. By the way, how much is that amount? How much current we have is time t? At time t, how much current do we have?
Dr. Godric,
Yes?
you're gonna be dropping an assignment on this. This look like something we need to practice on.
Yo, man, you haven't even gotten an assignment on this, and you talking about I should be dropping it? I don't teach so I could drop stuff. You need to follow what I'm doing, and if you don't follow what I'm doing, you need to ask questions. What have I done so far you don't understand?
No, I just wanted some practice, man.
Yes, and you will have to practice outside of class. That's what university is all about. For every hour you put in class, you should put in 2 hours where you practice what you need to practice. Now I ask again, anything I said so far you don't understand?
No, I understand what you do so far, but what if you try rearrange the question, to make it more complex? I could practice what you give me, but what if you twist the question in a way, what I don't
Mr.
understand?
Who am I talking to?
Doc and Anderson.
Mr.
Mr.
Anderson,
Adley.
Mr. Adley, Mr. Adley. Have I ever complicated questions? Have I not always given straightforward questions?
Yeah, that's true. But just because you did in the past, I mean, even
Mr.
in this class,
Anderson,
what
you
if
sound like you don't want to learn. You don't want to have to learn what I have to teach.
no, man, nine. I just asked for some practice problems.
But I haven't even finished. I haven't given you the theory yet of what I'm trying to give you.
I mean, for the last one we did, the one we did before this.
What the assignment before this?
No, not that one. This one here, what you did with the integral.
Miss Anderson, answer me a question. Did you pass Math 171?
Yeah, a long time, man.
Well, young man, you have to go back and revise Math 171. You seem to think it's my responsibility to teach you everything you need to know in this class. That is not true. You have to come in here with some prerequisites. You have to come in here knowing calculus. And if you don't know that calculus, you have to go and learn it on your own. That's how university works.
Okay.
All right, let's get back to the question at hand. What is the current at T seconds?
5 amps.
All right. I know why you said 5 amps, but let me play the devil advocate here now. What's the current at T amps? By the way, I will not be practicing calculus in this class. I want to make that very clear. You practice calculus on your own time if you need to practice calculus. This is not a calculus course, and you are expected to know how to use calculus by the time you get to this course. And what I did in the previous problem is nothing but calculus. I will not be spending a lot of time practicing calculus in this class. I ask again, what is the current at T amps?
Could we assume 0.5 amps or less?
No, you can't assume that. Why are you assuming that? Just like 5 amps when I drew T in the middle. That's why I moved there, so you can't easily guess at what it is. What is the value at T seconds? What is value of current at T seconds?
Would we have to use the equation of the straight line to figure that out?
Absolutely. We already did that. We already did that. Who's talking, please?
Stewart.
Mr. Stewart. So what is the value of I at T amps? That's the first thing we did.
1 second. It would be negative 5t plus 110.
No. I was so sure you had it. No, absolutely not. Stewart. At this time, what's the current? At this time, what's the current? A time t red, at red t. What's the current? This is telling me y'all don't understand functions very well. At time t, it is negative 5t plus 110. That's what that equation means. But that equation isn't the other straight line. What's the other straight line? Folks, the very first thing we did when we began this discussion was get the equations for I of t. Look at your notes I gave you. Look at the notes I gave you. What is the value of I of t between 0 seconds and 20 seconds? Because that's a straight line we want.
When you was doing the piecewise linear equation, you said a half a t for 0 is less or equal to t, and t is less or equal to 20 seconds.
So what's the value of I of t? Between 0 seconds and 20 seconds, what's the value of I of t?
Would it be t over 2?
Say again?
T over 2.
Absolutely. This equation is a half t. So at t, it is I of t is half t. That's the equation of a straight line. Right? And that is valid whenever we're between 0 and 20 seconds. That is not valid when we're between 20 and 22 seconds. When between 20 and 22 seconds, okay, the equation that is valid is negative 5t plus 110, 110. All right. So I'm going to do this non-calculus way first. I'm still between. So we're still talking about for this time period. We're still talking about this time period. Okay. So what's V of t for this time period? What's V of t for this time period?
Would it be 1 over 2?
Again?
1 over 2.
1 over 2? I don't think I'm getting through. I don't think I'm getting through this class.
Would we use
How do you find the voltage? How do you find the voltage across the capacitor?
1 over c times integral from 0 to 22? 0 to
Integral of what?
the current I.
E of t.
And what is this? What is that integral? What is that integral? So again?
Area under the curve.
Area under the curve. Area under what curve? Area under what curve?
From t 0 to t.
Area. Who was the last person who spoke? The last person. Go ahead.
I was saying from 0 to half a t.
Yeah, man. You confusing the x-axis and the y-axis. A half a t is the y-axis.
Would it be from 0 to t?
From 0 to t. See right here, it says so. It says from 0 to t.
So the guy, what's the question you asking?
Miss Pinto, where have you been? Where have you been for the past 10 minutes?
Yeah, the guy right is right there. I just missed the question.
No, you weren't.
That's all.
But I've been working on the same question for the past 10 minutes. And now you ask me what the question is?
I mean, cause you asking something at the moment right now.
Excuse me?
I just was, never mind. I can pick up.
Everybody, please pay attention, okay? I don't know what you're all doing in the background. I think we may have to go back in the classroom.
We ain't gotta do that now.
We may have to do that because Mr. Pindar, you do not pay attention when I talk. And this ain't the first time I've noticed this.
So the guy, I've been listening to everything you say. You was engaging with another student, and I just missed the last thing you asked because of the lag in the connection. That's it.
What don't you understand? Why you ask me what the question is then?
I understand what's going on. I just thought you was.
Tell me what's going on. Tell me what we're doing.
You trying to find the voltage at a particular point in time.
What point in time?
I ain't sure which point in time right now.
Well, that's the whole problem, isn't it?
I ain't sure which point in time.
Anybody, what point in time am I trying to find the voltage for?
at T,
Again?
at T,
Sorry, I couldn't hear the first part of what you said.
trying to find the voltage at point T.
At point T. And where's point T? Mr. Pindar, where's point T?
Where is point T? It's right on the graph on the x-axis.
Where?
You mean where? Beneath the half T. Beneath the line with the slope of half T.
Between 0 seconds and 20 seconds.
Right.
And this matters.
Okay.
This matters because the equation of the current matters. So we're trying to find the voltage at time T. So how do we find the voltage at time T, Mr. Pintard?
Plug it in, put the stuff in the definite integral.
And what are we doing?
Solve.
What is
define an area under that point up until time.
you don't find area in the point.
I mean under the line, under the slope, under the line slope. It's like a triangular area.
The area from where to where?
From 0 to T, go up to the slope, go up to the line.
The area under the curve between 0 and T. And how much is that area?
I don't know.
How much is that area?
I'm sure.
But Mr. Pindar, why not? How is this problem right now any different from the homework you handed in? The homework you handed in, you gave me the voltage at T equals 22 seconds. Or N plus 2 seconds. I'm not asking for N plus 2 seconds. I'm asking for the area at T seconds, where T I've identified on the graph. Anybody? What's that area?
Isn't it a half times T times the current?
And how much is the current? It's Beauchamp. I thought you had it. How much is the current?
The current isn't a half?
No. Look at the graph. The current is not a half.
You want a definite value for the current.
I want a value for the current. It ain't gonna be definite because the value for T is not definite.
Oh, okay. I thought we were using the same value from the question before.
I don't know why you think that. We've been on the same problem now for the last, it must be close to 15 minutes. And we ain't getting nowhere. And we ain't getting nowhere because I don't know why this is such a problem. What is the area we're trying to find? What area are we trying to find?
Yeah, yeah, okay, because I can remember what he said he was.
Turn your mic off, please. Thank you. What is the area we're trying to find?
That's the area between 0 and T.
All right. The area of what?
Under the curve.
All right. And what is the curve?
A straight line.
A straight line. All right.
You gotta find the y.
And so what is that area form? The area of what?
Triangle.
The area of a triangle. It's the same homework problem. So therefore, tell me, what's the area then? What's the area?
That's the same half times the time times the current.
And Mr. Beauchamp, we're back to where we started. What is the current?
Half of the time.
Thank you very much. Therefore, we have half the base, the base is T,
Times T over 2.
times the height, and the height is T over 2. And therefore, that is T squared over 4. That is the equation for voltage. That's T over 4. Do you see where you went wrong, Mr. Beauchamp?
Yes, sir.
Okay, good. There's nothing wrong with being wrong as long as you know that you. Excuse me?
Can you move the pen, please? I can't.
Oh, sure. Yes. So, when is this equation valid? Anybody? When is this equation valid?
From 0 to 22.
No.
So when the graph forms a triangle.
T.
Oh, from time from 0 to 20?
It is valid from, go ahead, Ms. Beauchamp. From 0 to 20, yes. That's when this equation is valid, from 0 to 20. See right up here? That's my first statement. Okay. Now, we got to divide by C. Sorry, we didn't divide by C. Did we divide by C?
No.
No, we did not divide by C. Divide by C. So this would be 12. T squared over 12. That's voltage at any given time. At any given time between 0 and 20 seconds, that's what the voltage will be. I know as I still didn't use calculus to find this. Let's prove that. Let's prove that. We can prove that. You know how we can prove that? Stop sharing. Please share from my PSpice now. Oh, who am I missing? Oh, I'm missing, what's his name? I haven't seen him in a while. Okay. Okay, there's my PSpice. There's my 3-farad capacitor. There's my piecewise linear current source. All right. So here's my current. There's my current between 0 and 20 seconds. It's a straight line of a half a slope, and then from 20 to 22 seconds. And now let me plot my voltage. And there it is. There's the quadratic. See the quadratic? There's the quadratic up till 20 seconds. And let's get the equation for that. We already got the equation for that. The equation for that is time times time. What was it? Divided by 12? Divided by 12. There it is. You see the blue is right on top of the red? That is telling us what? Yes, indeed, those two, the simulated voltage and the equation of the voltage over that time period is the same. But now what happens? They're not the same after 20 seconds. Why? Because we did not calculate the voltage for after 20 seconds. So let's do that now. Let's do that now. Let's calculate the voltage up to 20 seconds. Before I go on, any questions about this? Okay, I hear no questions. Excuse me? No, I made 30 seconds to end, but that's not the end of my graph. The end of my graph is 22 seconds. Then after that, everything's zero. But I wanted to show you what happens after 22 seconds for the voltage, because the current ended at 22 seconds does not mean the voltage did. And in fact, it does not. Again, voltage is not proportional to current in a capacitor. Voltage is proportional to area under the current. Okay, let me clean up now. Okay. Now here's my T. There's my T. So now this is for 20 seconds less than T less than 22 seconds. This is the time period we're talking about. All right, so we're here. So again, give me the equation for the voltage. So what is the equation for the voltage? Give me the starting equation for the voltage. Say again? Give me the defining equation for voltage as a function of current.
V at T equals 1 over C integral of 0 and T I d of T.
I dt, not I d of dt. I dt plus V0. V0 is 0 by assumption. No. What is this? What is that integral? I don't know if y'all noticed, but I ask the same questions over and over. Y'all,
That's the area under the.
y'all are stumped. Y'all are stumped every time I ask a question.
Oh, you got it. That's the area under the line from 0 to T.
Under what line?
Under the slope, the positive line, the one with the positive slope.
Absolutely not.
No,
On the
be
negative slope. No, from the negative slope. Maybe bad.
From
No,
20 to 2.
no, no. See here, look at it again. I don't know why y'all don't see this. From 0 to T.
Yeah. I say that.
0 to T.
But I say that
0
though.
to T. 0 to T. You said positive slope. That's what you said.
Oh, all right. But why you ask me which
This ain't
line?
this ain't positive slope, Mr.
Okay.
Mr. Bendard.
Which line it
Well,
is?
what slope? What slope is this? Look at it carefully. What slope is that? Just look at it. It is both slopes. It is from 0 to 20. It is this slope. It's this area here. Plus, it's this area here.
I know. I can see that, Dr. Cartwright. But why you
But
say
you didn't
which
say
line?
that
Why you say which line then?
because I wanted to test see which line you give me.
Was you saying
And the
that's a
answer-
trick question?
It is not a trick question.
Just two lines or one line. This one going up is one line and one going down is two lines, right? Or that's
Yes,
one
it's
line.
two. Yes, it's two lines.
Right.
And so I was testing your understanding. Do you think you only need one line?
It's both lines then.
And now you know it's both lines.
I ever didn't know that, Dr. Cartwright. You just tricked me in that question, man. That's words. I still don't understand what you were saying. I just the words is
Mr. Bentod, please.
I tell
All
you.
right? Please. So what is this area of? What is the total area? From 0 to 22, and so 0 to T. And T doesn't T. The last number of T would be 22. So how do we find this area?
Would you take the area from 0 to 20 and add it?
All right. So total area is area 1 plus area 2. So area 1 equals what? What does area 1 equal?
100.
All right. Well, what's a unit? What's the unit?
False.
Don't talk fool. What are you multiplying?
It would be amps per second.
Not amps per second, amp seconds. You multiply in amps, that's the height, that's amps, times the base. The base is time, seconds, amp seconds, not amp per second, amp seconds. Okay, amp seconds. What's area 2? What's area 2?
The integral from 20 to t.
Say again?
The integral from 20 to t.
All right. Dang it, help you anyway. Go ahead.
I think it's 5.
5 what?
Seconds.
Oh, you got that.
From 20 to t is only 1, and the height. No, that might be wrong.
Mr. Who am I talking to?
Johnson.
Mr. Johnson, you made this mistake earlier. I corrected it, and you're still making it again. Why do you think the distance between 20 and t is 1? Why do you think that? Did I say t was halfway? Did I say t was halfway between 20 and 22?
No, sir.
So why you assume that it was?
When y'all was talking about the total area plus
T is any value between 20 and 22. Any value. It just so happens I drew it midway. That does not mean it's midway. So before you can find that area, too, you need to know the height. You need to know this height here, don't you?
Yes, sir. That's what I realized. I made a mistake.
And what's the value of that height? What's the value of that height?
I think it's 5 ohms.
Well, you get 5 again from Mr. Israel. You don't learn. You're not learning. Again, you think it's 5 ohms because it's midway. But I just finished telling you it is not midway necessarily.
Not in that negative 5t
I was thinking
over the time.
No, it's not 5t over time, Mr. Buchamp. Where you got that from?
I mean the equation of the line over t.
Ed, why are you putting the equation of the line over t?
But you're trying to find the I, right?
I'm trying to find the height. I'm trying to find the value at t. I'm trying to find the value of I of t at t.
I'm thinking the value would be t over 5.
Y'all do not understand functions. Is this point right here? Is this not on the straight line?
Yes, sir.
So that's a point on a straight line. What's its value?
It would be negative. It would be negative t over 5.
Wow. Y'all just gave me this answer. Y'all just gave me this answer about half an hour ago. And now when you need to use it again, you can't use it again.
Are you referring to the answer you said half an hour ago? Are you referring to the negative 5t plus 110?
Yes,
So-
because that's the equation of the line. That's what you need. That's what you need. You need to know if that value on the x-axis, if that's t value, what's the corresponding y value? The corresponding y value is the equation.
Mr. Carter, they said that.
No. You did not say you were dividing by t.
I said the equation of the line. Yeah, but I said divided by t. Yeah.
There's nothing being divided by t. Why do you think something's being divided by t? It is simply negative 5t plus 110.
So all that is the height.
Yes.
All right.
Now I ask. Now comes the front part. Now I ask, what's the area of 2? What's the area of 2? What's the area of 2? My God, I'm gonna run out of time. And all I'm teaching you all how to do is define areas. That's all I'm doing. Actually, no, I'm teaching you all how to, what a function means. You don't even know what a function means.
Dr. Cartwright,
God's work,
Yes.
Doc.
saying that T is any area between 20 and 22, could I just... could you
T
just
is
say
not
T?
any area. T is not any area between 20 and 22. T is a particular value between 20 and 22.
Could I leave it as T instead of giving it a value?
That's exactly what you have to do.
Alright.
It isn't a question of can you. It is a question of the answer is you must. If you don't know what the value of t is, how are you going to evaluate it? You're going to have to give me a formula. You cannot give me a number. How are you going to find the area? Second area.
Okay, T times negative 5T plus 110 divided by 2.
You're just making shit. You're just making shit up.
I know the angle triangle no more, so we can't use that baseline height formula.
All right, Mr. Bootchamp. Can you make it a triangle? Plus
Okay.
something else? Plus something else? Can you make
Triangle plus a square.
can you make area two different areas?
Yeah, you can, but it may be a little complicated.
It ain't gonna be no complicated.
You just draw a line over the top, go across to the left.
All right, let's do that. So area 2, the total area 2. Let's split the 2 into 2 and 3. Let's split area into 2 and 3. What's area 3? Yeah, let's do area 3. What's area 3?
That's a half.
Mm-hmm.
Times this is, I can't even say the height.
You don't know the height?
No, because I know. Because out of line, draw a straight cross height.
So you don't know the height of this triangle. That's what you're telling me? Okay, let's do area 2 first then. Let's see if that helps any. Let's do area 2 first. What's area 2?
That's length times width.
Which is what?
Yeah, that's I know that the length is from 20 to T.
The width is T minus 20. That's the width, T minus 20. What's the height? What's the height?
Negative 5t plus 110.
Thank you very much. I don't know why it took so long for that. If this height is negative 5t plus 110, then this height must be the same thing. Minus 510 plus 110. Yes. So that's area 2. And we could, so that's negative 5t squared plus 110t minus 100t minus 2200 equals minus 5t squared plus 10t minus 2200. That's area 3, area 2, sorry. That's area 2.
So for area 3, it could be half. So the height of this top of the triangle, that could be 10 minus negative 5t plus 110.
Absolutely. Because from here to here is 0 to 10. From here to here is, this is 0, this is negative 5t plus 110. And so the difference here would be this height. So area of 3 is half the base. And the base is t minus 20. And the height is 10 minus negative 5t plus 110. Let's clean that up. Plus t minus 20. Okay. 10 plus 5t minus 110. And we need to divide by 2. Okay. Now let's make that another quadratic. Let's put it, let's simplify it. So area 3, area 3 equals 10t plus 5t squared minus 110t minus 200 minus 100t plus 2200 all over 2 equals 5t squared so that's 100 100t minus 210t, okay, minus 200, minus 200t, plus 2200 all over 2. Okay, unless I made an error there. Did I make an error there, anybody? So the total area then, the total area is area 1 plus area 2 plus area 3. So area 1 was 100, area 2 was negative 5t squared, plus 110, no, plus 10, minus 2200, plus 5t squared, minus 100t, plus 1100. Hopefully I didn't make an error. So that is minus 5t squared. That's that and that. Okay, that's 10. So 10t plus minus 90t minus 90 minus 90 minus 1100 minus 1000. All right. Okay, that's the total area. Let me put 22. Let me put 22 into that. T equals 22. How much area would that be? That'd be negative 5 halves times 22 squared minus 90 times 22 minus 1000. And I've got an error here. I've got an error here because the error is negative, and clearly the error is not negative. So I made an error somewhere. How much should the area be? From 20 to 22, how much of the area should be? So we can easily check our answer. How much should the area be?
Should it be 20?
Should be how much?
Oh, 20? From 20 to 22, the area would be
From
20
20
times seconds.
How do you get 20?
Say from 20 to 22, it should be the area of 1 of the total minus
It's just-
1.
No, look at the graph. It should just be the area of that triangle.
Yeah, oh, I thought you'd already find, so you're going to just subtract it.
The area should be from 20 to 22, the half the base, that's 1, times the height should be 10. The area should be 10.
I got 10.
That's 10, right? And then the area between 0 and 20 is how much?
And that was 100.
100.
100. So the total area should be 110. And that's not what I'm getting. Therefore, I made an error. Therefore, I made an error. So my time is up because I have a class at 12. I want you and me to look to see where I made an error in calculating the area.
You can put
I don't,
the paper up so I can take a picture.
yeah, sure. Hold on a sec. You got the full screen?
All right. So I guess if we find the way you made a mistake, we get a bonus pointing. So
I'm not assigning marks to this, but clearly I made an error somewhere.
I talking about the previous homework.
No. The previous homework is history. The previous homework is history. All right. So next class we'll pick this up. Next class, because remember, what are we trying to get now? What are we trying to get? Let's not lose sight of what we're trying to do. Let me stop sharing here. I am now trying to find the equation of the voltage between 20 seconds and 22 seconds. That's what I'm trying to do. And this is the method we could use to do that. Notice I'm not using calculus yet. Well, we're going to do calculus because this is a calculus-based course. And those of you who don't know calculus for whatever reason, you need to go and learn it on your own. Okay. So I will leave that. I'll try and find out where I went wrong, and we'll continue this next class. Any other questions or concerns? I'll see you on Wednesday then.
Thank you.